I even looking at? We're not doing that today. We're doing OBS. Oh, did I not even show? Oh, goodness. Reading your own rights. Let's see. Brutal. Let's see here. This goes. Something's wrong. Oh, wow. I just didn't log lunch at all. I just do this right now. Okay, that's done. And then this has that. Okay. Alright, where are we? Reading your own rights. So actually first we need to do this. Let's see, what are key characteristics of the relational model? SQL, tables, schemas. It tastes like garbage, dude. As soon as they put M&Ms on it, it's no good. I regret eating that. Um, okay. What are the key characteristics of the relational model? Schemas, SQL, uh, tables, relationships. I think that's good. Structured data with schemas, SQL, tables, normalization, and decades of tooling. I don't think this is really that important. Enforces normalization and strong consistency. How does graph model represent data? Through a series of nodes and edges, where nodes are entities and edges are relationships. Nice. What are the downsides of imperative queries embedded in application code? A tighter coupling of business logic and data access logic. Error prone, harder to optimize. When is the document model when your data looks like a document, when you need what's it called, data locality, when you can tolerate data duplication. SS table is it's a data store backed by an in-memory data structure that once it gets large enough, it'll become a segment file, and it keeps everything sorted to make compaction and merging easier. Compaction means taking multiple segment files, taking the most recent entries and removing all the rest to reduce the footprint. Duplicate keys away and keeping only the most recent. Nice. In a B tree, an orphan page is a page that has no references to it. Data outlives code is the idea for a database that the data that's stored could be years old, while the code that has to retrieve it could be written tomorrow. A message broker is an intermediary that an intermediary that producers and consumers interact with. It decouples. It removes the request response lifecycle, and it abstracts the end destination away. whatever. Client is someone who connects to a server, makes a connection to a server. Yeah. A web service is any service that uses HTTP as its communication protocol. Compatibility, when we talk about backward compatible, it means whatever that is writing the data and reading the data works. The relationship, one process that between, okay, the distributed actor framework. The distributed actor framework. This isn't a very good ticket. Because like as I remember this, it doesn't really make any sense. But each service would be an actor that can communicate. But no message is guaranteed to arrive, but everything's working independently. All right, dude. I don't know. Merits of schemas, code generation. Code generation. What else? Formal documentation. Oh, they can be serialized easier or to better formats. So they take up less space. Can be more compact, yeah. Some advantages of a message broker. I talked about this. Separates, it gets rid of the request response cycle. Anyone can consume a message. You can automatically retry if a service is down, and it abstracts the end service away. Act as a buffer too. Yeah. What are the pros and cons of binary encoding? Better methods of compression. Is compression the right term here? I think so. I don't know actually. Hmm. Um, Better serialization formats. Maybe I should just go with that. But then you have forward backward compatibility, and then you have there's something else here. Oh, it's hard to get people to agree on encodings, so you can usually only do this internally. Horizontal scaling is more or less powerful machines. Catch-up recovery. Oh, okay. So in a for replication, right? Replication, handling node outages, follower failure. Yeah, catch-up recovery. So if a follower fails, they keep a log of all updates, and then you can just request every update after that log. You apply those to the DB, and then you're caught up. Failover is a huge mess and is a problem. Basically, if the leader fails, then you need to designate a new leader, and when the leader comes back online, you need to tell it that it's now a follower. You also need all the followers to recognize the new leader. Yeah. Some replication log implementations. Some replication log implementations are, oh shoot, this is a tough one. It's brand new. Learned it yesterday. I think it's the write ahead log. Append only log, write ahead log. I don't know if that's right. I have no idea. Statement based replication. That's right. Write ahead log, and then the logical one, and trigger based. I don't remember what trigger based was. The statement based. I can't remember what any of these are. That was hard though. Replication lag is when writes go to the leader, but don't get applied to a follower until later. This is a problem because when if the leader goes down, the new leader that gets designated doesn't have those rights, and now, oh no, that's not what I'm. That's wrong. Replication lag. It was the same thing where rights go to the leader, but they don't immediately go to the follower, or they might not. And in those scenarios, when the user tries to look at their updates, they can't find them. Data inconsistencies, cool. That one was good. All right. So these probably need to be let's just. So many applications let the user submit some data and then view what they have submitted. This might be a record in a customer database, or comment on a discussion thread, or something else of that sort. When new data is submitted, it must be sent to the leader, but when the user views the data, it can be read from a follower. This is especially appropriate if data is frequently viewed but only occasionally written. With asynchronous replication, there's a problem. If the user views the data shortly after making a write, the new data may not yet have reached the replica. To the user, it looks as though the data they submitted was lost, so they will be understandably happy. That's right. In this situation, we need write after write, read after write consistency, known as read your writes consistency. Okay, so I'm just so distracted. Um, in this situation, we need is okay. Flashcard. Is a guarantee if the user when reading something that the user, like, dude, I cannot focus. When reading something that the user may have modified, read it from the leader, otherwise read it from a follower. This requires that you have some way of knowing whether something might have been modified without actually querying it. I still, dude, I don't know what I just read. When reading something that the user may have modified, read it from the leader. Otherwise, read it from a follower. This requires that you have some way of knowing whether something might have been modified, okay, without actually querying it. For example, user profile information on a social network is normally only editable by the owner of the profile, not anyone else. Thus, a simple rule is always read the user's own profile from the leader and any other profile information from a follower. Okay. If most things in the application are potentially editable by the user, the approach won't be as effective, as most things would have to be read from the leader, negating the benefit of read scaling. Okay. In that case, other criteria may be used to decide whether to read from the leader. For example, you could track the time of the last update, and for 1 minute after the last update, make all reads from the leader. You could also monitor the replication lag on followers, but then you need like another store tracking that and you could also monitor the replication lag on followers and prevent queries on any follower that is more than 1 minute behind the leader, okay? I see. So you could almost like keep a Redis cache. I'm imagining you could keep a Redis cache that all writes go into, and then the TTL is like a minute or two. So you could check Redis real quick and say, oh, the data's there, send it back, because this was a recent write. Okay. The client can remember the timestamp of its most recent write, and then the system can ensure that the replica serving any reads for that user reflects updates at least until that timestamp. If a replica is not sufficiently up to date, either the read can be handled by another replica, or the query can wait until the replica has caught up. The timestamp could be a logical timestamp or the actual system clock. Okay. Wait, what? If your replicas are distributed across multiple data centers for geographical proximity for their availability. There is additional complexity. Any request that needs to be served by the leader must be routed to the data center that contains the leader. Yeah. Another complication arises when the same user is accessing your service from multiple devices. For example, a desktop web browser and a mobile app. Oh, I see. In this case, you may want to provide a cross-device read after write consistency. If the user enters information on one device and views it on another, should see the information they just entered. There's additional issues to consider there. Approaches that require remembering the timestamp of the user's last update become more difficult because the code running on one device doesn't know what updates have happened on the other device. This metadata will need to be centralized. If your replicas are distributed across different data centers, there is no guarantee that connections from different devices will be routed to the same data center. For example, if your user's desktop uses a home broadband connection and their mobile device uses the cellular data network, the device's network routes may be completely different. If your approach requires reading from the leader, you may first need to route requests from all of the user's devices to the same data center. Okay, there's a lot here. It's a lot of problems, bro. Why do I keep misspelling this? Okay, I got like nothing done today, dude. What the heck? Alright. Good enough. Oh, you're kidding, dude. I can't.